space is a hostile environment for human life. Without the protection of Earth's atmosphere and magnetic field, the harsh conditions of space can pose serious risks to the human body. One of the most pressing questions for space exploration is how long a human can survive in the vacuum and radiation of outer space. The first thing to consider when discussing survival in space is the lack of breathable air. In the vacuum of space, there is no air to breathe, which means that a person would quickly lose consciousness due to the lack of oxygen. Without immediate intervention, this would lead to death within a few minutes. However, if a person were to be exposed to the vacuum of space but somehow managed to hold their breath, they would still face other serious risks. The extreme cold of outer space, with temperatures as low as 270 degrees Celsius, would quickly lead to hypothermia. Additionally, the lack of atmospheric pressure would cause the water in a person's body to vaporize, leading to swelling and tissue damage. In addition to these immediate threats, the long-term effects of space exposure also pose significant challenges to survival. The high levels of radiation in space can cause serious damage to the body's cells and DNA. Prolonged exposure to this radiation can lead to an increased risk of cancer and other health problems. Despite these formidable challenges, there have been instances where individuals have survived exposure to the vacuum of space. In 1965, during the Gemini 4 mission, astronaut Edward White performed the first American spacewalk. During this historic event, White was exposed to the vacuum of space for approximately 20 minutes and managed to return safely to the spacecraft. This demonstrated that it is possible for a human to survive brief exposure to the vacuum of space, provided they are able to return to a pressurized environment within a relatively short period of time. In terms of long-term survival in space, the current record for continuous time spent in space is held by Russian cosmonaut Valery Polyakov, who spent 437 days aboard the Mir space station from 1994 to 1995. This extended mission provided valuable insights into the effects of long-duration spaceflight on the human body. Polyakov's experience demonstrated that it is possible for humans to adapt to the microgravity environment of space and survive for an extended period of time. In recent years, there has been renewed interest in long-duration space missions, including potential missions to Mars. These ambitious plans have sparked research into the physiological and psychological challenges of extended space travel. Scientists and engineers are working to develop technologies and strategies to support human health and well-being during prolonged missions in the harsh environment of space. One approach being explored is the use of advanced life support systems to provide astronauts with the essentials they need to survive in space, including oxygen, water, and food. These systems would need to be highly efficient and reliable, as there is no opportunity for resupply once a spacecraft is en route to its destination. Another key consideration for long-term survival in space is the psychological well-being of astronauts. The isolation and confinement of space travel can take a toll on mental health, and it is essential to provide support systems to help astronauts cope with the challenges they may face during extended missions. Overall, while surviving in space presents significant challenges, it is clear that humans are capable of adapting to and thriving in this extreme environment. With ongoing research and technological advancements, it is possible that we will see even longer missions into space in the future, opening up new frontiers for exploration and discovery.